Hello everyone, in this video we are going to discuss differentiability and continuity tests. Now we have a question which says test for continuity and differentiability at x is equal to 1 for f of x equal to x and the ranges of values of x less than or equal to 1 and f of x is equal to x cubed for values of x x greater than 1. Now for continuity and differentiability, we know they move together, but we know that for differentiability, at any point, the function has to be continuous. So before we go to differentiability, we must test for continuity at x is equal to 1. So recall the limit as x tends to c, f of x must exist. In other words, we are saying if c is equal to 1, the limit x tends to 1 must exist. And this limit will equal to, we are saying limit x tends to 1, f of x must equal to f of 1. So if we say that limit exists, that limit also as x tends to 1 for this function, then it must also equal to the value of the function at x is equal to 1. So what does that mean? Since this is a piecewise function, we are going to use limit x tends to 1 from the right. This is from the left. From the left, f of x will equal to limit as x tends to 1 from the right. This is from the right of f of x must equal to, this limit must exist of course, and must equal to f of 1. So now what is which side will give us limit as x tends to 1 from the left? So these are the values of x. We have, if this is 1, so these are the values of x less than or equal to 1. And these are the values of x less than or x greater than 1. So that means if we limit x is equal to 1 from the left, we are talking about these values of x less than or equal to 1. So we shall say limit x tends to 1 from the left of x must equal to, this is going to be 1. When we substitute in the value of x, we shall find that that value of x equal to 1, we are getting 1. So what about if we limit x is equal to, okay, if we limit the function f of x, okay, as x tends to 1 from the right, okay, what function or what value of f of x are we taking? It must be x cubed. So this is going to be x cubed. So if I put in 1, this is equal to 1. And it can be seen that f of x at x is equal to 1 is equal to 1 elsewhere. And so the function is continuous at x is equal to 1. So that's one. We have seen that the function is continuous at x is equal to 1. So the continuity test is done. So let's look at the differentiability test. So the differentiability test says if we differentiate, or if we get the slope of this function on the right hand side and we get the slope of this function on the left hand side, the two values must be equal for the function to be differentiable at x is equal to 1. So we take the two sides of x is equal to 1, one where we have x greater than 1 and where we have x less than 1. So if we find that the two sides are giving us the same value of differentiation, or the same value of slope, then we shall say that the function is differentiable. Now let's go ahead and try. So the easiest way is to look for f prime of x. So f prime of x will equal to, here we had x, so it will be 1. This is for x less than or equal to 1. Then we have here 3x squared for x greater than 1. Now we can see that the two values, the slope of the function is different, okay, on the either sides of x is equal to 1. Therefore, the function is not differentiable at x is equal to 1. If you wanted, we could also take limit, okay, limit of the function f prime of x as x tends to 1 from the left, okay. What would this value equal to? This is equal to 1. So we also take limit as x tends to 1 from the right of f of x. We find that this is the same as 3x squared, which is 1 squared, and this is equal to 3. The two values are different. So limit of f of x as x tends to 1 from the left is not equal to the limit of the value of the function of f prime of x as x tends to 1 from the right. So since they are not the same, the function is not differentiable. Not differentiable at x is equal to 1. As simple as that. So there are two ways. You can either differentiate the function and look at the two values, or you can limit from either sides as the value of x tends to that value as you approach it from the different sides of that value.